My name is Bruno Borges. I'm a product manager for Latin America. I cover WebLogic, Glassfish, and Java EE. If you know Arun Gupta, I'm a good friend of him, so I basically do what he does around the world. I'll be doing in Latin America. Just for you to get to know me better, I'm a Java developer since 2000. I speak at conferences for a while. I've been doing that for a few years. I used to evangelize Apache Camel and another framework, Apache Wicked, in Brazil a lot. I'm going to actually give a talk tomorrow about Wicked. I joined Oracle recently to do exactly what a product manager does, an evangelist for Java EE. And now, well, I live in São Paulo. I have a golden retriever, marriage. I like to do video games and hike when I'm not playing video games. So we are here to talk about enterprise patterns, enterprise integration patterns. How many of you are aware of what integration patterns are? Okay, good. That's good. And how many of you have heard about Apache Camel before? Awesome. How many of you can do Scala coding? Okay, not so awesome. But I'm sure everybody knows Twitter, and what is cool about this talk is that I actually use Twitter as the data source for introducing you Camel and Scala. So, well, most of you know about this. How many of you have this book? If you are into enterprise integration patterns, you have to have this book. All right, it's like the Bible. Everybody have it. And this is a quote from Randy Stafford, a guy from Oracle. It's on that book. If you are involved with the operation of enterprise applications, there will doubtless come a time when you need to integrate your application. So it's impossible to imagine a world where we have independent applications living alone, not integrating with something else. So there will be a time, maybe sooner, maybe later, but you will have to integrate that application with something else. Then you're going to have to learn enterprise integration patterns. So why do we need? Well, I just said that. Why is it so hard? Because it deals with asynchronous messages. That's kind of complicated. You have to be aware of all that data coming from somewhere and going to somewhere. You have to control the state and so on. It's very hard. Where and when? Well, I think all the questions are very connected. And in my opinion, it's like cloud computing depends on it. You cannot do cloud computing without actually thinking about asynchronous messages. And when you think about asynchronous messages, you're going to have to think about enterprise integration patterns. So then comes up Apache Camel, a framework that has been being developed. I'm terrible about English. Camel is from the Apache Foundation, and it's like 10 years, I think, maybe more than that people are coding that framework. So it's an implementation for those patterns. With the Camel framework, you can design the routes to manipulate those messages moving around. You can use out-of-the-box components that comes with Camel. You can develop your own components, like I did with Camel Twitter. Of course, asynchronous and synchronous messages, you can do that too. And most important, connect distinct and independent systems, which is basically receive, transform, and deliver data. So the architecture behind Camel is basically these kind of things. There was a talk yesterday about Camel, and I think it was Kai, his name, and he gave a very good introduction. So if you missed that, I'm going to just give you some points. So components. Components are about the system that you are going to connect to. So let's say an FTP component. That component has the knowledge to connect to a server and extract data or upload data. You have endpoints. which is what a component creates for you. An endpoint is the actual connection for some FTP server. You have routes. This endpoint connected to this endpoint. This is a route. And we have exchanges and messages. What the endpoint sends to the other endpoint, it's an exchange. And on that exchange, you have messages. It can be an in message, an out message, an in-out message. All that is about enterprise integration patterns, actually. And you have consumers, producers. The consumer basically is the part of the endpoint that connects to the actual data, the system, and gets the data from. And producers are those parts of the endpoint that uploads the data to that external service system. And processors. Processors, they are where all the magic happens, what you do with the data. So if you transform the data, if you enrich the data, if you split the data, and so on. So this is a very quick overview. Let's say we have two queues. We are getting messages on queue A, and we have to put some of those messages on queue B. How we do that? We think about one pattern here. We have the message filter pattern. So the QA is getting a lot of widget quotes and gadget quotes. We want to put on QB only the widget quotes. So we apply the message filter pattern. So thinking about the logic here is just that from QA, we're going to filter that and send to QB, which in Camel, it translates basically to this kind of Java DSL. So it's very straightforward. It's very simple. The Java domain-specific language and the Spring XML domain-specific language for Camel, they are very tied. They're very connected to the enterprise patterns here. So we can actually think about the pattern when we see the code. This is a more complex route. Actually, it's not that complex. I've seen worse than this. But it's a route that will connect to a file, actually a folder, and we'll try to see new files coming into the inbox. It's a polling endpoint component, endpoint. And for every file that comes here, it will create an exchange, put that file, a reference for that file on the exchange, and then you can process with the processor, for instance, the XPath processor here. So it will get the XML data, and with XPath, we can filter basically based on that data. And then we will dynamically route to some other endpoint. So for instance, we have widgets coming from the file going to the endpoint widget and gadget to the gadget endpoint, just like the pattern says for. Now, Scala, it's one thing that I really like about Scala is that you code even less than in Java, way more, less than in XML. So as soon as you get to know a little bit about Scala and the details about the domain-specific language from Camel for Scala, you can do in 2 lines a message filter. You can, not really 2 lines, the line was broken. This one is a router, so it gets very, very simple. It doesn't look beautiful at the beginning, but then you get used to it. All right. So what else about Camel? So like I said, we have DSL for Java, Spring XML, and Scala. Camel provides a standard URI for endpoints. So we will always see endpoints like this, direct, double dots, and some name. Or more specific, file, which calls the file component, and then some path. So the first part of the URL is the schema, which connects to the component that is able to deal with that URI. So we have Also, we have lots of components, like the Apache Camel provides you lots of components. You can just do whatever you want. You can even, let's say, connect to a RESTlet and send data to RMI, ERC, IRC, Hibernate, JPA. You have AES 400. I don't know what that is. Sorry. We have Mail, LDAP, and so on. So those are just a few of the components that I could list for you here, but it actually has more than, I don't know, 50 components. And I'm just saying about the components that are provided by the Apache Camel team from the Apache Software Foundation. So of course there are more components. Kai was showing the source Salesforce component that he's working on. So you can actually do your own component, connect to some cloud service, and do whatever you want. One cool thing about the last version of Camel is that it integrates with CDI. Until the last version, you would need a web application to start your Camel context to give like to really start processing the messages. Now with CDI, you don't even need a web module. You just need a AGB3 single tall with a startup. So then you start the context, and there you go. About social media, social data. We have Twitter on this talk. So social media, the rise of social media as a communications channels. This is an article from published by Oracle. It's called 2001 Customer Experience Index Report, the era of impatience. We are very impatient now on the internet. So let's say almost 30% of consumers post negative comments on the internet. Almost 50% have posted negative comment following bad customer experience. So social media and social data, it's very important for customers, for business. We have to get that data and do something about it, right? Because if you look at the end, 30% that get responses, 51 had positive reaction after. So if your business gives a response to that negative comment, the consumer will have 51% of giving a positive feedback on that one. And 13% deleted their negative post, which is, well, doesn't work on the internet. When you post on the internet, it lives forever. But at least they do something about it. So Twitter, for instance, we have almost 4,000 tweets per second. At the beginning, it was like 2,000 per day. Now we have 4,000 per second. We have peaks for almost 20K tweets per second, FIFA World Cup or something big like that. One tweet, this is interesting. One tweet have 140 characters, we all know that, but the message actually gets 540 bytes because of the encoding. And we're not even thinking about the raw data that goes to the database. So storing all that data requires a lot of storage, right? So we have to deal with that when we think about social media, social data, how to process that. And we are not even talking about Facebook or Google Plus here. This is a very interesting code. It's not information overload, it's future failure, right? There's a lot of information on social media. We have to know how to get it and what to get it. Because if we get a lot of data and we don't know what we are getting, processing that much data is going to be even worse. So I was wondering if I could use enterprise integration patterns to actually get that data and do something about it. So I was thinking I can read status updates on Twitter. I can filter based on keywords. I can identify the issue that the user is having with the customer. Then I can route to someone that can give him a response based on that experience, reply if possible, and store for future conversations. And then we can customize as needed. So thinking about that, I came up with the Camel Twitter component a few years ago, 2009. I blogged about this, which is actually the title of the session on 2009. wondering if we could use those patterns to process that data. So I submitted to Apache the ticket Camel 1520. I was at the Apache Con 2009. I talked to the committers about this idea, and there was a challenge because the committers said, you know what, why just Twitter? Why not every social media? But, you know, I thought, yeah, sure. So I came up with Camel Social. The goal was simple, a component that could be able to get data from any social network. The URL was beautiful, like social, the social provider, and the parameters. That could be like beautiful. But, I mean, this is the examples that I was wondering about. Let's say I want to tweet something, so I'm going to send some information coming from that endpoint that goes to social, Twitter provider, and the status. That was the original idea. Or something to Facebook. Or searching events on Facebook. So, oh, by the way, this is the Scala DSL. So this was the original idea, but it failed. It failed because it's not easy to standardize the social data that comes from different social networks. It's not easy. The Spring Social team, they are working really hard on that. And from my understanding, it's not, they have different APIs for each social network. Well, if you do that, that's okay. So then I would have to come up with each component from Camel for each social network that would work. But doing one abstract API for every social data, that's impossible, right? So it could bring the component back to life. If some one of you are interested about this project, I welcome you to get the code and try to finish. But this guy, he was thinking like me. It's not easy to do an abstract API for every social network. So he called me, sent me an email, and he asked me to upload the code to GitHub so we could work together. And the original code is on my GitHub. And also another guy, this is Brett Meyer. He just joined the Hibernate team from Red Hat. Ryan, Eugene Bryan, he added support for this Twitter streaming API, which I'm going to present to you on the demonstration. So I owe a lot for these guys. And none of them could come to Java 1, but I really appreciate the help they gave me. So final version, 2010, 2.10. That's the version that provides Camel Twitter. You can, with that version, that component, you can tweet updates. You can search. You can connect to the streaming API. You can read direct messages. You can read, this is interesting, you can read retweets, mentions, or the home timeline of some user. Of course, all that provided by the Twitter 4J API library. It got an Apache license recently, so that's why also enabled the component to be available from the Apache Software Foundation. So if you remember the social component, it's quite the same, but of course behind of that, there's an API very tight to Twitter 4J and Twitter itself, but the idea is the same. So here we want to send a tweet from JMS. We just put this line on a route using Scala, and then every string that comes from that JMS queue will go to the Twitter status update. If I want to read tweets, I can pull every 5 seconds and log the tweets. That's, I think it's, does anyone of you have worked with Twitter 4J before? Nope. It's not that easy to get tweets from Twitter 4J. It's at least 5 lines of code. But with the components, really easy. Here I want to do dynamic search on Twitter. This is a feature that I provided recently, a few weeks before they released the 2.10 version to provide dynamic keywords. This is wrong. From that endpoint, if it comes with a header, that header has the dynamic keyword that I'm going to search. So then I can do whatever I want. I don't have to change the endpoint every time I want a different keyword. So I think I'm okay. I think we have time. So I'm gonna do the Twitter demo for you. I don't know if any of you was getting my tweets on Twitter. I actually put the demo online. It's bit.ly Java1 live. So this is the application running on Amazon EC2. It has a HTML5 front line connecting with WebSockets to Apache Camel. And what Apache Camel does for every tweet that comes from that search, Java1, OW, it sends a message, a JSON for every user connected on the WebSocket server. So it's very, very, very simple code. It was originally coded by Ofibesian. He came up with this during the Olympics. So what he did was a page like this one, but searching Olympics. That's all. So when we click, we can see the bigger image. All right, so let me show you the demonstration. So what I'm going to do here is run the same code that I'm running on Java1 Live. I hope it works. I like to use Maven a lot. No, it's wrong. Let me start the other one, the other sample here. Oops, not this one. You know, when you work with Twitter and you want to make a demonstration, you have to be careful which keywords you're gonna choose for the demo, because people are nuts on Twitter. They post weird stuff. I mean, really. I mean, is there how many women are there? I'm sorry for asking this. 1, 2, 3, 4, 5, 6, 7. All right. Damn. I mean, if I just put like pic from pictures, I get so many pictures being posted on Twitter, like 40 pictures per second. But for every 10 pictures, 2 are just not rated. I mean, it's crazy. People are crazy on Twitter. I mean, I think Twitter is the most porn server on the internet, really. I lost myself here, sorry. All right, let me change the keyword. TDC on Camel, searching for Batman. Can anyone give some term that I could search for? Yeah, people are not tweeting pictures on Java1. I mean, people are just tweeting, not picturing. Right, let's see what's trending on Twitter now. Let's see if we can get pictures from trends. Okay. Yeah, I'm the Java1 parties. All right, it's trending National Boyfriend Day. All right. All right. Let's see how that goes. I mean, it's risky. It's risky. Yeah. Oh, let's see. Beer. I don't know. People. Yeah, let's see. Compile. Oh, I'm going to take the rest tag off. Just beer. There's also a porn beer category, you know. Somebody comes up with that someday. All right. There you go. We are connected online and streaming through WebSocket. Oh, this is the disclaimer, but it's in Portuguese, all right? Yeah. Okay, it sounds good. No, sounds good. All right. Damn. Not beer. All right, National Boyfriend Day. Damn. Let's see. Oh, I put the hashtag. No, it's okay. Well, it's trending on Twitter, so let's see how that goes. Oh, the disclaimer again. You see how hard is it? Is that? Obama, that's good. Obama, is there any Mitt Romney supporter here? No? All right, let's say Obama. Oh, no. What? Yeah, someone supporting him. Obama, you know. Let's see. Oh. When I started working on this demo, I was like, man, like the humanity has no way to go. Like, it's like destiny are doomed.
Normally the demo will fail in a different way. For you, it's a different way.
Yeah. Come on, Obama. Oh, Dexter. I love Dexter. All right. See, porn again. But soft porn at least. Okay. Justin Bieber. Is that you? It's kind of porn. Yeah. So what the route does is actually it's covering the tweets. Can you see the number going up? So it's actually connecting all the tweets, and for every tweet that it gets, it checks if it has images on it, and then the first image he sends a JSON object through WebSocket to the page. Yeah, Obama. Yeah. See, so it's kind of cool. You could put like a huge monitor on your room and see what's going on the internet. You know, kind of live, porn live. it's funny. So let's see some code. Let's see how this works. I'm gonna show you a little bit of Java DSL first, and then I'm gonna show you the Scala version of the same route that I created here. So this is the main code for this. Let me explain to you. All right. So can you people back there read the text? No? Good. No, I'm kidding. Let me put a bigger font here. Font size, colors and fonts. What? On the base. I didn't understand. I'm telling you where the font, the text font is set. Oh, okay. I think this works. Okay. Okay, so here's the route, the Java DSL route. You see, first, let just explain to you. I have a processor for just the statics that I'm getting from Twitter. So I keep an instance, an object on memory, getting those stats. So it's a very simple processor. So let's say, so this is the processor. For every exchange that goes through it, if it's a status, I just increase the tweet count. If it's a tweet, that's my internal class that, because it was already filtered with an image, then I increase the image and tweet count. And that goes into that statics object, which is just a POJO, right? So I keep the started on property that I can get the uptime Some of you are seeing the uptime down right at the end of the page. So if I want to clear, just call the clear method. So all right, coming back to the route. So for every tweet that I get from the route, this is the sample route. I using the type event that actually connects to Twitter, opens a streaming channel, then tweets sends me. The component has a few options. It can be an event like that. It can be pooling. So your component, your endpoint will connect to Twitter every amount of time. There's an option to filter, to automatically filter old tweets that you are getting again. It's true by default. So then I send to SEDA images, which is an endpoint and a synchronous endpoint, right? This one. So for every exchange that comes through this route, I extract the image. I call the statics processor to get the data that I want to save. And then I filter the body. From this part on, only tweets with image will continue. Then I make a throttle. I make it slower. So then I want like send a bunch of data through WebSockets. Marshal with JSON, and then I send to WebSocket through all the clients connected. You see, there's an option here: send to all. All right, because WebSocket, some of you may know, WebSocket is able to send just for a particular connected user. What else? Oh, the statistics, they are sent to the WebSocket using Quartz. So every second, I send the statistics through WebSocket in a different WebSocket channel on the same page. So then I have that update on the top. On the bottom is just a JavaScript that gets the date that the server started on, and then a JavaScript just keeps going up. What else? I have a WebSocket for statistics, so I can send a message through JavaScript that clears the statistics. And also I have something really cool that is an API that enables me to change dynamically the route of of my program here. So if I send a WebSocket message that starts with search and then something, I remove, where's the route? Set keywords, add routes. Where's the remove route? It has to be some oh, here, remove route. So when I get a message from WebSocket that says sample or search, I'm able to stop the route, remove that, and add a new route dynamically in runtime, right? The component, the framework is able to do that. All right, what else? Oh, here's the component being configured. And then I have the access token, consumer, and so on and so on. So this code, if you want to take a look at it, all right, Obama. If you want to look at it, it's on this code, this particular Java code is on GitHub, Bruno Borges /TDC on Camel. Okay, this is the specific code that I presented in the last conference I gave a talk in Brazil before coming here. This is the Java version of the route. So TDC on Camel, Bruno Borges /TDC on Camel. Now I'm going to show you the Scala version of that route. You see how much code was in there? So, well, when I saw the announcement of Java 7 with Lambda expression, I was, yeah, maybe I won't need Scala anymore, which is good. What? I have to wait 2 years. Okay, Scala then, for a while. Yeah, I'm a Scala fan. As a developer, I'm a Scala fan. Okay, so this is the Scala version. All right. So the Scala version is no, not this version. I'm sorry. I have two demos here. One is the one that is online on Amazon, which is the Java one Live, and the other one is a tuned version of the route. Okay. So when you connect to the server for the first time, so let's say bit.ly Java 1 Live, you see that you already got a few images, right? Because that came from the server giving you the last 12 images that they got for you. I added this feature last night because what was happening is that we were connecting to the page and we were getting nothing until someone actually posts something on Twitter. So the page would stay like nothing going on for a while. So I just added that. So I came up with this FIFO blocking queue with 12 items. It's a LRU type of queue. So what I do, I'll just show you the Scala code. If the remaining capacity is equals 0, I just remove the last one and offer the new one. So it's very straightforward. Okay, I have the JSON format component here, the message transformer. I have the header, and then I get the keywords from the configuration file. All right, this basically is the route. This is the Twitter route that actually sends tweets to the browser. All these. So what I do here is I connect using the filter type endpoint, using the event type of connection with Twitter, which gives me the streaming API on Twitter. And I add the keywords that I get from the configuration file or the command line. I process the tweets using the statistics, and then I filter. When this underline here is the exchange coming. It's very crazy, but you got used to it. So the underline means the exchange. So I get the in message inside the exchange, and then I get the object as an instance of status. And then I see if I get media entities inside the tweet. Right after, I convert the tweet, the status update, to a my tweet object, which gives just the user, the text, and the image URL. Then I move to the process of the LRU images to get the last 12 images on memory. So I just offer the body to it. This is a functional expression, a lambda expression that Java 8 will have now. Then I marshal for JSON, and then I send to the WebSocket. So here is the send to all again. And statistics, how do I send that to users? I just give them the statistics every second, marshal to JSON, and there you go. And those first 12 images that I get from the browser, as soon as I connect to the page, this is the route that gives that. I get the URL LRU images list. I split that into several exchanges, and then I marshal each one to JSON and then deliver to WebSockets. Then there's a JavaScript on the client side that gets that data and show that data on the browser. So I think, what else can I do? Oh, yes, continuing the presentation. The last thing. So this is just what I showed to you. So what I did was connect to the search streaming. I filtered tweets that have media. Oh, yes, let me show you the enhanced demo with Oracle Coherence. So Oracle Coherence is a cache, distributed cache that is able to store stuff in a crazy way. That's how I describe it. So here I have instances of coherence, one here, another one here. They all talk with each other using UDP. So they know about each other in using broadcast communication. So if I shut down this instance, all the other ones get to know that one instance is now down. So if I come with this instance back again, they communicate each other through the network, and then they start to share the data in a concise way. So I'm storing tweets here. If you see, I already have 33,886 tweets stored on memory. So when I was talking about social media and social data, is that we need some stuff like this to store the data. And if we want to get more data, we can just come up with new instances. So then you have more space in memory. Then you can run your code, search for some stuff that you want. You aggregate data to get statistic data based on tweets that you get. It's really cool stuff. So, what?
I mean, I know Coherence for 3 or 2 times, but I think it's quite cheap.
It may be. Well, there are other products on the market that can do that. It's just that Coherence has a very straightforward way, no configuration. It comes a lot of cool stuff by default. You know, you don't waste your time tuning that much. So for this demo, it was actually the perfect fit, because what I wanted was an in-memory storage for as much tweets that I can get based on memory that I have. So if I come up with more tweets that I can handle, Coherence will throw up old data to give space for the new tweets coming. So basically, it makes sense. If I want to treat social data, I don't actually need the data 3-4 years ago. You know, I just need the recent data, like trending topics, those kind of things. So for this kind of feature of analyzing, it does great, pretty much the job done. So the demo with Coherence, it will check the Coherence cache for tweets and filter duplicates. If it's not there, it will add as a key value. The key will be the image URL and the actual tweet as a value. Then I go forward as the rest of the demo. So let me show you that particular demo here. Okay, TDC on Camel is out. Let me connect to the Camel Twitter Coherence. All right. Okay, receiving status stream. Let's see the size. 32,999. Oh, connected. The coherence component for Camel, it also brings up an instance of the cache, so they all communicate again. So 32,971. So let's see what's going on. Oh. What's going on here? This is not my... Okay, got it. Okay, let's stop all the instances. Bye-bye. And then let's change the keyword for this one. Main resources, app, the proxies down. The keyword is Batman. No, Batman is a bad one. Let's say Java 1 OW. There we go. Yeah, it started Coherence because I'm using the Coherence component for Apache Camel. I don't need them yet, but if I want to increase, I just start a new Coherence cache server instance, and then they will communicate with each other automatically without configuration. That's the basic, the default connection. All right, so now let me connect to the console. Okay, so you see that's why I hate the Java one and OOW. What?
Hobbit.
Hobbit. This?
No. H-O-B-B-I-T.
H-O-B-B-I-T? Okay. All right. Whatever you want. Yeah, like cosplay stuff. I mean, it get nuts. The first time I gave this talk, I wasn't using images, just text, and somebody said, I was explaining, somebody said, look those hot chicks on the hall. And everybody started laughing. Then I looked, oh, okay, got it. Let's go to the hall. The talk is over. Let's see. Come on. Okay, Hobbit. Okay, 3 tweets. Can you come up with a better keyword? All right. What? Amsterdam. That's a good one. Amsterdam. There you go.
You're begging for it. Sure.
Amsterdam. Nope. Is it spelled right? Yeah. 1 tweet, 2 tweets. One cool thing about Coherence is that if you look, no, not cool yet because there's no image. It only stores tweets with image on Coherence. That's my route definition, right? You know what? I'm gonna go with hard stuff. Just don't look to the screen. Because what is cool about this is that it's really fast, you know? I'm gonna turn off the throttling. So then if something comes up, we can just, move. Let me open the route, and then I'm gonna show you the throttling working. So here's the aggregation pattern for Scala DSL. So what I do here is, there's so much tweet coming that I only want to send to the WebSocket, let's say 1 tweet per second or 1 tweet per half of a second. I have like 30 tweets per second. So what I do is I aggregate whatever strategy I use, but I get a lot of tweets in these 500, and I only get the last one of those tweets that I got in 500 milliseconds. So what I'm going to do here is turn off this, so then it's not going to be slow. It's going to be really fast. There you go. Not aggregating. Compile, ASAC. It's going to be like peak, so it can come up with anything. I'm so sorry, ladies. All right? Not my fault, Twitter's fault. They are not filtering. You know, I was actually looking for an algorithm that could be able to detect porn on pictures, but nobody came up with that yet. So there you go. There's a chance, you know. Yes, there you go. So a lot of stuff coming from Twitter, really fast, porn stuff as well. And this is the humanity we live in, you know. This is the live streaming of our society. Congratulations, society. I mean, crazy stuff. So I can slow down a little bit, yeah. I can slow down a little bit, but then the image will like... And no matter what image comes up, you're gonna look at the porn stuff. You know, your brain goes that way. It's really cool stuff, really funny. Oops, so there you go. I have one thing here, is the publish. I'm just going to show you the tweeting sample, the retweet sample. So I'm going to change, this is the last demo, right? I'm going to change the keyword just so I don't get that kind of stuff. And Java 1, okay. Oh, by the way, Coherence was running, so let's check the cache. 3,500 tweets on those minutes, right? Okay, connected again to the application for Java 1 and OW. Let's see. Okay, so see, nobody is tweeting about anything. So what I'm going to do here is try to tweet for you something. Let's say, okay, Wi-Fi connection on. Yeah, no demo for this part. But I'm gonna tweet something. Let me show you. Let me open the console. Let me open the WebSocket JavaScript that I'm using to tweet for you. I have the app retweet, this one. Okay, so app retweet dot start. Oh, there you go, one. That's me. That's me. That's me. All right, cool. Thank you. Thank you, sir. So let's tweet that using WebSocket and Camel. Okay, so I'm gonna copy this one here. I'm gonna start. It started, and I'm gonna retweet whatever you send to me. Here, there you go. Done. Let's see on Java 1 parties. Oh, there you go. Java 1 parties. That's the retweet. Okay, so it's kind of inception, isn't it? Yeah. Okay, so the code is quite simple. It's just one route, a small route, this one. So I expect something coming from through the WebSocket endpoint retweet, and I got exchange. I set a body which RT plus the message that came up, and I just sent it to Twitter, and that's it. Okay. So it pretty much sums what I wanted to show to you. And let's see if I have any more slides here. About Camel Coherence, just the last one to finish, to sum up what I wanted to tell you. So I'm working on the coherence component that it's a fork of the EH cache component, the Camel cache component. So I replace the EH cache and just put the Oracle coherence component on top of it. So then I have the same features of that component. I can add, check, get, remove, or remove all entries from the cache. I can, then I can use that URI, which is pretty much simple. The coherence / Camel cache name. Coherence is LRU by default, which for this demo is really cool, really great. It's also good for social data caching in memory. If you need more storage, just deploy a new coherence instance on your network. And then those instances will connect with each other and gives more space for data. All right? That's it. Any questions? No? Yes?
How does it sounds a lot like what I've heard described as like an enterprise service bus. What would you see the difference being between Camel, as you described it, and
Okay.
ESB? Because it sounds like they do some of the same things as far as like bridging endpoints and configurations and whatnot.
Yes. Like Camel is basically the framework for using enterprise integration patterns. You don't have monitoring, you don't have start-stop, web console, administration, features like that. It's just really the framework. So you have to program every single thing that you want to do. So if you want to monitor live things that are going on, you have to build your own console for that. If you want for enterprise service bus, most of the products, they come up with that. You just deploy the routes. If you get, for instance, the Apache service mix, that ESB can deploy Apache Camel routes So then service mix manages the Camel routes. Okay.
Would it be fair to say that the features that you get in Camel might be a subset of what an enterprise service bus would be?
Yes.
Is that a
Yes.
fair characterization?
Yes. Anything else? You ready? Okay. I hate it. I mean, yeah, they're doing a great job. I mean, I'm not following very close, but well, they are trying to catch up. I mean, Camel is on this for years, and Spring people they have come up with Spring integration like 2 years ago, 3 years ago. But they're doing a great job. I mean, well, you can use Spring to define the Camel routes as well. Okay. Any more? Nope. Okay. Well, thank you very much.